Hello everyone. This is our another series of questions for average and RMS value of different waveforms. First we analyze this question. In this question, it is a stepped up square waves that are periodic in nature with time period 12 seconds. And for the half cycle, that is 6 seconds, it is positive, and for another half cycle it is negative. So this type of waveforms having average value for a complete cycle is 0. So here we analyze the average value for the half cycle. For half cycle, if you analyze this current waveform for time 0 to t, it is 0 ampere, time 1 to 2, it is 5 ampere, 2 to 3, 10 ampere, 3 to 4, 15 ampere, 4 to 5, 10 ampere, and 5 to 6 is 5 ampere. Now analyze the average value. Average value is area of cycle in time divided by total time. So here we take our time is 6 seconds. So the average is area for time 6 seconds. First 0 to 1 second, its value is 0, 0 into 1. And if you analyze the time for time 1 to 2 second, its value will be 5. So it is 5 into 1. Similarly, next 2 to 3 second, its value will be 10. 10 into 1 rectangular wave shape plus is 15 into 1, and 4 to 5, it is 10 into 1. 5 to 6, it is again 5 into 1 divided by total time, that is 6 seconds. And if you calculate this value is 45 by 6, and the calculated value of average current is 7.5 ampere. Now calculate the RMS value. RMS value of a periodic waveform is defined as square root of area of I square cycle in time t divided by total time t. In symmetrical waveforms, if you analyze the value of I square, each value will be squared. Okay? The I square wave shape will be like this. For time 0 to 1 second, it is 0. For time 1 to 2 second, it is 5 square. 2 to 3 second, it is 10 square. 3 to 4 second, it is 15 square. 4 to 5, it is 10 square. And 5 to 6, it is 5 square. Now calculate the RMS value. IRMS is square root of area of I square in time t. That area is 0 into 1 for 0 to 1 second, then 5 square into 1 for time 1 to 2 second, then 10 square into 1 for 2 to 3 second, 15 square into 1, 3 to 4 second, 10 square into 1, 4 to 5 second, 5 square into 1 for 5 to 6 second, divided by total time is 6 second. Now calculate this RMS value. It is square root of 475 divided by 6, and if you calculate this value, that is 8.89 ampere. This is the solution for symmetrical type of waveforms. Let's analyze the average and RMS value of this waveform. This waveform is periodic with time period 4 seconds, and if you analyze this waveform 0 to 2 second, it has ramp nature. 2 to 3 second, it's constant function, and 3 to 4 second, it is a rectangular waveform, and its maximum amplitude is 10 ampere. Now analyze the waveform function for the time 0 to 4 second, that is the time period. Time period is 4 second. Now see the current values for the time 0 to 2 second. It is a ramp function, that is 10 by 2 is the slope, that is 5 into t. Slope of this waveform, that is y is equals to mx, that m is 10 by 2 into t. And now see the value of 2 to 3 second. It is a constant 10 ampere. And if you analyze this for 3 to 4 second, it is also minus 10 ampere rectangular wave. So this is the function of current waveform for different instant of time. Now analyze the average and RMS values from this current wave shape. I average is area of cycle in time t divided by total time t. Here you can see three areas of this cycle. This is our first area, this is our second area, and this is our third area. So now calculate each area. For area 1, that is half base into height, that is a base is 2 and height is 10. So its value is 10. For area 2, base is 1 and height is 10. It is also 10. For area 3, our base is 3 to 4, that is 1, and height is minus 10. It is minus 10. And the total time t is 4 seconds. So the average value for this waveform is A1 plus A2 plus A3 divided by total time t, that is 10 plus 10 minus 10 divided by 4. So the average value is 10 by 4. 10 by 4, that is 2.5 ampere. Now analyze the RMS value. The RMS value is square root of area of I square in time t divided by total time t. Now analyze the I square waveform. For I waveform, it is 5t and it is 10 and it is minus 10. So if you analyze the I square for time 0 to 2 second, it is 5t square. For time 2 to 3 second, it is 10 square, and for time 3 to 4 second, it is minus 10 square. This is the current waveform I square t. IRMS is square root of First area A1 of I square, area 2 plus area 3 divided by total time is 4 seconds. If you analyze this area 1, that is I square, that is 5t whole square. This area is for the time period 0 to 2 second, I square t dt, or you can say it is 0 to 2 second 5t whole square dt. So this is 5 square is 25, and integration of t square is t cube divided by 3 for a limit 0 to 2 second. Now this is calculated as 25 divided by 3 into 8. Now calculate area 2. Area 2 is simply 10 square into 1, that is 10 square, and if you analyze the area 3, that is minus 10 square into 1, that is 10 square. So put all these values for the RMS calculation, that is square root of area 1 is 25 into 8 divided by 3. This is 10 square and this is also 10 square divided by 4. If you can solve this equation, then the IRMS will be square root of 200 divided by 3. This is the solution for such kind of waveform where the function varied for different section of time. Let's analyze average and RMS value of this waveform. Its first half is same as the previous question, and second half is the symmetrical of first half. So for this waveform, for the complete cycle, the I average will be 0 for complete cycle. And if you analyze the average value for half cycle, if you analyze the I average is area of cycle in time t. As we discussed earlier, this waveform current for 0 to 2 second, it is 5t, and for 2 to 3 second, it is 10 ampere. So if you analyze the area, this is divided into two parts. So area of first part is half base into height, that is 10 into 2, and for next part this is 10 into 1 divided by total time period is 3 seconds. So it is calculated as 20 by 3. Similarly, we can analyze the RMS value. If you analyze the RMS value, for RMS value, this current waveform I square will be periodic for 3 seconds. For RMS calculation, we will calculate the RMS value for the time 3 seconds. Formula for the calculation of IRMS is area of I square in time t by 2 divided by total time t by 2, as this is a symmetrical waveform, and for this waveform I square is periodic with t by 2. So for concentrating the section t by 2, there are two different wave shape. For 0 to 2 second, you can calculate the I square, and 2 to 3 second, it is 10 square. Now calculate the area. There are two area as we calculate earlier. Area 1 for 0 to 2 second, integration of I square t dt. So it is 0 to 2 second. This waveform is I is equals to 5t. This is 5t square dt. We calculate this in the previous slide, that is 25 into 8 divided by 3. And our area 2, that is I square, that is 10 square into 1, this is 10. So it is calculated as 100. Now calculate the RMS value. This is IRMS is equal to square root of area 1 plus area 2, that is 25 into 8 divided by 3 plus 100 divided by total time, that is 3 seconds. The calculation is square root of 500 divided by 9, that is 10 by 3 square root of 5 ampere. This is the solution of RMS value. So hope you understand the concept of average and RMS values for the different types of waveforms.